Okay, we're going to do another example, and this one's a little bit more obscure. It might take a little bit to digest all this, but we have an arc cosine function of 4x. We're going to find the tangent line at x equals 0. And remember, the word tangent means at one single point where the line, a line that hugs the curve. So we're going to take a look at what that graph looks like. So again, determine an equation of the tangent line for arc cosine of 4x at x equals 0. Now, just so you're aware, there's another way of writing this function, and it's this way, okay? It means cosine inverse. It's the same thing as arc cosine. They are interchangeable, so keep that in mind as you're solving this problem. These two mean the same thing. Whoops. These two mean the same thing. Okay, let's keep going. Here's the graph of our function, arc cosine of 4x. Here is what it looks like at x equals 0, so we can see a point, looks like around 1.6. I believe that's pi over 2. And here's what the tangent line looks like. We want to figure out what is this equation of this line that touches this point, touches the graph exactly one point, and only one point at that location. Again, this is at arc cosine of 4x at 0. We're going to follow the same steps as the previous example. We're going to plug in 0, our x value, into the function and figure out what the y value is. For step 2, arc cosine is 0 because on the unit circle at pi over 2, okay, the x value is 0, and we know that cosine is 0. So remember, when you do the inverse cosine, you're given the x value, and you have to find the angle, as opposed to giving the angle and finding the x value for a regular trig function. Now we're going to take the derivative of our original function so we can figure out the slope of our tangent line. Using derivative rules, derivative of arc cosine is -1 over square root of 1 minus x squared. In this case, it's arc cosine of 4x, so we plug in 4x for the x, and then use the chain rule to take the derivative of 4, and 4x is 4, and multiply by the derivative. So this is chain rule mixed with arc cosine rule. We'll simplify this by just simply tucking this 4 up to the top, and 4x quantity squared equals 16x squared. So here's our derivative. Now we're going to plug in 0 into the derivative to see what the slope of that line is. So we plug in 0, we get -4 over the square root of 1 minus 0, and square root of that gives you square root of 1, which is 1. So we get -4 over 1 as our slope. Okay. So basically, just going back to the graph, we've figured out the slope of this line right here to be -4, which seems about right. Okay, keep going. So now we're going to write out our slope. Since y prime of 0 is -4, f prime of 0 is -4, then m equals -4. We're going to write out the equation for our line, y equals mx plus b. We're going to plug in the first y value that we found, which is pi over 2. The first x value that we're given, the slope that we just found, which is -4, and the x that we're given is 0. So we're going to figure out b, so we're going to get pi over 2 equals b, right? And so pi over 2 is our y-intercept, which initially, what I told you, looked like it was about 1.6, and that is what we've just confirmed here. So now we're going to write y equals mx plus b, but we're just going to plug in our slope and our y-intercept. And again, that's about 1.6. So there's our equation, folks. Y is equal to -4x plus 1.57, and that is the equation of this tangent line of arc cosine of 4x at x equals 0. Pretty simple. If you have any other questions about tangent line equations, let me know. Remember, just so you don't get confused, the equation for a tangent line is different than the derivative equation. The derivative equation is useful when you plug the x value in, you find the slope of the tangent line, but to find the tangent line equation, you also have to find the y-intercept. Again, if you have any other questions about that, let me know.